Hello, welcome to my channel. In the topic magnetic effect of current, today we will study the force acting between two long straight current carrying conductors, and we will define standard definition of ampere. We know SI unit of current is ampere, then how it will be defined, today we will learn. Before that, we have learned the force acting on a current carrying conductor placed in magnetic field and so on. So we will discuss how a current carrying conductor placed in magnetic field experiences a force, and when then two current carrying conductors are kept parallel to each other, then what happens and how Ampere's definition is made. Before proceeding further, I would like to say please subscribe my channel and press the bell icon for further notification, so that you can get definition of ampere and also some important questions asked in the board as well as competitive examinations. So stay till last of the video and see what is the definition, how it is derived, and what is force. Let us discuss. With the previous video, we have read that force on a current carrying conductor kept in magnetic field and how the things are interconnected. You know, when the single charge is moving in the space in the magnetic field. So here the concept begins from that this is the free electron, and when electron moves in the conductor where the conductor's end are connected with the cell, then electron moves opposite to the applied electric field or opposite to the direction of current. So we can say that I into L, or this current element or part of length of conductor MP, IL. So L is in this direction and VD, that is drifting of electron or motion of electron, is in opposite direction. So you know, when the electron or charged particle experiences a force when it moves in magnetic field, we have read this is Lorentz force. What is Lorentz force? This is minus E QVB. So this is Q minus C V into B. We have read yesterday in the previous video. Now all the electrons will move in this direction, then what will be the net force? So F net will be total number of electron into this, and we have read this total number of electron, and AL is the cross-sectional area, L is this length into this one minus E VD cross B. We have read this. Since this I into L in this direction, VD in this direction, so we can write here that LVD, if it is written here like this, can be written as minus VD L. We can assume. And what will you do? That I equal to NEA VD, then F net is equal to N, bring E outside the bracket, E A L within bracket. This is NEA VD within bracket, L B, and now L and B both are vectors, and this is I. So we have learned here that IL cross B is the net force acting on the wire. So this is the force acting on the wire. When a current carrying wire is placed in magnetic field, this magnetic field is upward. This all we have seen yesterday. How this minus and this minus, it becomes IL cross B, and these are the three vectors. So Lorentz force is force moving on a charge in magnetic field, and vector sum of all the Lorentz forces flowing through a conductor, that is, you can say a current carrying conductor is placed in the magnetic field, then the force acting on it is F equal to ILB. Both the direction of Lorentz force as well as direction of the force on current carrying conductor, both directions are determined as usual by Fleming's left hand rule. Now today, if there are two conductors, long straight conductors, and they are placed parallel to each other with the certain distance apart from, like this I am showing that if there is a conductor, long straight conductor having current I1, and from the distance, at the distance r, perpendicular distance from it, another wire, parallel current carrying conductor is placed. Then how the force will act in between them and what will be the definition of ampere. So we will study today the force between two long straight current carrying conductor placed parallel to each other. What will I do? Look, this is the wire number 1. What will happen that if it carries the current I1, as usual, you know the magnetic field will be produced by the current carrying conductor. So magnetic field is direction is determined by the right hand thumb rule. So look, at the distance r, suppose at this point P, the fingers are downward due to curling of the finger, magnetic field direction is decided. So here at point P, suppose this is the point P, the magnetic field, this cross magnetic field will be due to the wire 1. So what will I write here? This B1, and what is the formula for that? B1 equal to mu naught I1 upon 2 pi r, distance between. Now at this point P, passing through this point P, another wire having current I2 is placed parallel to first. What happens? First you draw one wire, then find magnetic field, now you put the second wire. So passing through P, if the second wire is placed parallel to first one, suppose this is the second wire, and if the current in this wire is also in the same direction as I1, now what will happen? This wire is supposed to be placed in the magnetic field of first wire. B1 is what? Magnetic field produced by the first wire. So in the B1, current carrying conductor I2, current is flowing through that, is placed. What will happen? Before that I discussed that whenever a current carrying conductor is placed in magnetic field, then it experiences a force. Same thing will happen here. What will happen? The force will act on the wire and direction of force will be determined by Fleming's left hand rule. So before deriving the expression for force, look here the direction. In the second wire the current is upward, and in the Fleming's left hand rule, this is the direction of current, this is the magnetic field, and this is the force. Look, magnetic field is perpendicular to the plane downward, this is, current is upward, so you do your left hand like this. Now middle finger is I2, it is denoting I2. This finger, forefinger, is in the direction of magnetic field. Where is the thumb? Towards first wire. So the force at this wire will be towards the first wire. This force, suppose this force is acting on the second wire, its name is F2. What will be its formula? You have determined the direction. F2 will be, in the previous expression you have read, IL cross B. What is I in this wire? I2, you put the suffix 2. L on its unit length, suppose L length, so L is the length of the wire. And what is B? In which magnetic field F2 is acting on the wire, second wire? This is B1. So listen again, that B1 is the field produced due to current carrying conductor first one, and in this B1 the current carrying conductor second one is placed having current I2. So this is the force acting on this wire, and direction of force is towards the first wire. Now what will be the expression? You can write here, this is F2 upon L as I2 B1. You will write here B1. And why not I2 LB sine theta, theta will be 90 as usual. This is angle, perpendicular distance. So look here that I2 B1, put the value of B1 mu naught upon 2 pi I1 upon R. This force per unit length on the second wire, it can be written as F equal to mu naught upon 2 pi I1 I2 upon R. What is this F? F2 by L. And this is the expression from where we define the ampere. SI unit of current is ampere. Its standard definition 1 ampere is defined from this formula. How? Look here again. How to make sentence? If there are two long straight current carrying conductors placed at the 1 meter distance apart from each other in air or vacuum, if on their unit length, this is F2 by L. So if on their unit length the force is 2 into 10 to the power minus 7 Newton, then current flowing through them is 1 ampere. Again I am going to define. Look, what is this F? You can write here this F as F2 by L. So in some books it has been written that force per 2 into 10 to the power minus 7 Newton per meter. So by this. And if you are saying on their unit length, then you can say only 2 into 10 to the power minus 7 Newton. So listen again, in air or vacuum, if two long straight current carrying conductors having current are placed parallel to each other at the distance of 1 meter apart from each other, then if on their unit length the 2 into 10 to the power minus 7 Newton force attraction or repulsion, this force is force of attraction or repulsion X, then current flowing through them is 1 ampere. Listen, why attraction or repulsion? Look, this is the force acting towards the wire 1. What will be here? Due to the second wire, if suppose there is a point P dash, I take a point P dash here. Due to the second wire current I2, what will be the magnetic field at P dash? Again you use the right hand thumb rule. You find thumb in the direction of I2, then current, then magnetic field lines are upward. So here the magnetic field lines are upward. Now this wire will be supposed to be placed in the magnetic field created by second wire. Hence it will also experience a force. How will you determine the direction of force? Using Fleming's left hand rule. Now the P dash magnetic field is upward, so you have kept the forefinger upward. But current is in the direction here I1 like this, you rotate your hand like this. So look here that at P dash this is the magnetic field, this is the current, and what is thumb? Towards second wire. So in this way at this wire the force will be F1. Same F2 I2 LB, what will you write here? F1 I1 L cross B, and what will be B? B2. What will be B2? Need not to write again, I am writing here. B2 will be same mu naught I2, B2 is produced due to second wire, so mu naught I2 upon 2 pi R. So what will be F1 by L? What will you get? Mu naught upon 2 pi I1 I2 upon R. So look, this you can also say the current force per unit length. Same expression in magnitude, F1 by L and F2 by L both are same. Here you can write u mu naught upon 2 pi, and this is I1 I2 upon R, and this is F. What is the difference? That at this wire the force is towards first wire, and at the first wire force is towards the second wire. What will happen if the both wires carry current in the same direction? The nature of this force is attractive. So there will be attractive force produced between them if the direction of current flowing through them is same. Look, what will happen if direction of current is made reversed? If this is the direction of current, suppose second case direction of current is reversed, what is going to I am going to change? Look, due to the first wire the current I1 B1 will remain same and it will remain downward, and at this what will be the direction of force? Look, that magnetic field is cross but current is downward. Where will be the force? Where is the thumb? Away from the wire. So in the second case what will happen? This F2 will act like this. Is it or not? Same expression you will get, put the value of F2 by L, and you will get this one, force per unit length. Now come to the first wire. Since I2 is downward, what will be the magnetic field at P dash? Look, out I2 is downward, so right hand thumb rule, this curling of the finger. So look here, that this curling of the finger gives that at P dash the curling proves the magnetic field is downward. So what will be the direction of magnetic field at P dash? Cross. Since current is upward, what will be the direction of force at this wire? Why I am using both the hands? To determine the direction of magnetic field, right hand thumb rule. To determine the direction of force, Fleming's left hand rule. Look here, current is upward and magnetic field is cross. So magnetic field forefinger, now this current is upward. Look, where is the thumb? Away from the first wire. So not in this direction. What will be the force acting on the wire? In this direction. This will be F1. How are they acting? This is called force of repulsion. Same expression you will get here, but the direction changes because the I2 is reversed. What is the conclusion? That if two long current carrying conductors placed parallel to each other have current in the same direction, then there is force of attraction between them, and if they carry current in opposite direction, they repel each other. That is, force of repulsion is produced between them. How is the 1 ampere defined? In air or vacuum, two long straight current carrying conductors are placed at the distance of 1 meter apart from each other, and if on their unit length 2 into 10 to the power minus 7 Newton force of attraction or repulsion. Here repulsion, if the current is in same direction, then attraction. So if on their unit length a force of 2 into 10 to the power minus 7 Newton attraction or repulsion acts, then current flowing through them is 1 ampere. In this way you have to define definition the ampere. One question is asked in NEET exam, and it is given that there is a current carrying wire and current flowing through it is I. So suppose this is the wire, long straight wire, and the current flowing through it is I. Near it, a square loop of dimension L, each side is of length L, is placed like this, and direction of current through the loop is this. Suppose this is I dash, and this is L, and this distance is given L by 2. This is L by 2 and this is L by 2. The A, B, C, D this is the loop. Find the net force on the loop. What will be the net force on the loop? See the logic. If the current will flow in this direction, then AB is at the distance L by 2 from the long straight wire. Suppose this name is XY. So in the same direction the current will flow, then there will be attraction. So FAB will be the force of attraction. What will be the formula for force? You have seen here that F equal to mu naught I1 I2 L upon 2 pi R, and F upon L you are knowing. This is the side L, you can write. So this will be FAB and this will be the force of attraction. In place of R you will write here L by 2. So you write here L by 2. At the CD, since the current will flow like this, A to B, then B to C, then C to D, then C to D and this XY. What will be the force? Repulsion, opposite direction current. So what will be the force between FC at the wire FCD? Same mu naught I1 I2 L upon 2 pi distance. Look, this total distance. L plus L by 2. What is that? 3L by 2. What will be the nature of this force? Repulsive, because this one is attractive, same direction current, and this one is repulsive, opposite direction of current. So what will be the F net? F net will be FAB minus FCD. So in this way you can solve and find what will be the answer. So what is definition of ampere? How the force act between two long wires when they carry current in the same direction and when they carry current in the opposite direction. I hope you must have understood. Thank you.